As we continue working with parallel lines in 3-3, well, I say it's 3-3, but we're proving lines parallel, we want to go back and make sure that we are comfortable with our relationships that we just reviewed and we just were talking about. And when we're talking about parallel lines cut by a transversal, and we have these definitions of corresponding angles, alternate interior angles, alternate exterior angles, and then same side interior angles. So we should be able to go even farther back and make sure that we remember a linear pair, which are two adjacent angles that form 180 degrees, and then of course vertical angles. You know, those are just definitions that we are going to continue to use throughout geometry. So we should be able to look over here in our diagram and we should say, okay, well, an example of a linear pair would be angle 2 and angle 4, because angle 2 plus angle 4 is going to give me 180 degrees. And oh, by the way, that is also a straight line. We have vertical angles. Vertical angles are going to be opposite angles, and those are also going to be congruent. So angle 1 and angle 4 would be a vertical angle and congruent. So just remembering that. So as we talk about two parallel lines, which A and B here are going to be parallel, and they are cut by the transversal C, corresponding angles. Corresponding angles would be an example. Angle 2 and angle 6 are corresponding angles. They are in the same orientation. Alternate interior angles. Okay, when we're talking about interior angles, we're talking about inside my two parallel lines and alternating sides. So angle 3 and angle 6 would be an alternate interior angle, and also 5 and 4 would be alternate interior angles. And looking at alternate exterior angles. So alternate exterior, when we talk about exterior, we're going to be outside of the parallel lines, right? So we're going to be over here in this area or this area. So alternating exterior angles would be angle 1 is an exterior angle, and its alternate would be angle 8. So alternate exterior angles would be congruent. Angle 1 is congruent to angle 8, and then angle 7 is congruent to angle 2, because those are alternate exterior angles. And then continuing on with same side interior angles. Well, we have same side interior angles. So again, same interior, we're talking about between the parallels, and same side would be 3 and 5 would be same side, and 4 and 6 would be same side interior angles. So again, as we talk about those, we have angles 3 and angle 5, or angles 4 and angle 6, and those are going to equal, again, 180 degrees. My same side interior angles are going to be 180 degrees. My alternate interior angles are going to be congruent, right? These guys are going to be congruent to one another. My alternate exterior angles are going to be congruent to one another, and then my corresponding angles are going to be congruent to one another. So just keeping that in account. And I know that linear pairs right here, they're going to be 180 degrees, and they are also going to be adjacent angles, and then vertical angles are those opposite angles which are going to, by virtue, be congruent. So those are just some of the things that we need to remember. And continuing on with the conditional statements here. Conditional statement is a conditional statement. A conditional statement is a logical statement written in if and thens. So an example, given what we know that, so if a transversal intersects two parallel lines, okay, so I have two parallel lines, and we'll call that line L, line M, and we'll make sure that they look parallel, right? So I identify them as parallel, and we have a transversal that intersects them. Then we know if a transversal intersects two parallel lines, then the resulting corresponding angles are congruent. So I know that angle 2 is going to be congruent to angle 6 because those are corresponding angles, and corresponding angles are congruent. Now that conditional statement also applies. Not only if we know then that, guess what? Then the resulting, you pick it, the resulting same side interior angles equal 180 degrees. So we know that 3 and 5 added together, same side interior angles, are going to be 180 degrees. We know that if this transversal intersects two parallel lines, then my opposite exterior angles are going to be congruent. We know then that my interior, alternate interior angles are congruent. So these are conditional statements. If this happens, then we know this. So that's what they're talking about here, and that's sort of how it helps you to determine relationships in geometry, because they may not say it outright or they may not identify it as a given statement, but it should be through definitions and theorems and postulates that we learn these things. So as we try to use some of this information, let's see here. It looks like I, in this example, have two parallel lines, P and Q. Two parallel lines, P and Q, and they are cut by a transversal. So the things that I should be able to identify, well, I should be able to say that, well, it looks like X and Y. I have angle X and angle Y, and they are going to be same side interior angles. Same side interior angles, and they should be hopefully equal to 180 degrees. I want you to be able to make that determination. I should also be able to see that angle X and angle Z, angle X and angle Z, they are corresponding angles. They're corresponding. And if they are corresponding angles in this situation, we know then that angle X is going to be congruent to angle Z. Corresponding angles are congruent in this situation. And then possibly another thing that you might notice is that angle Y plus angle Z should equal 180 degrees because they are a linear pair. So we're just using our definitions to figure out, what the heck's going on around here. So another example here, we have, if angle 1 is 110 degrees, what would the other angle measures have to be in order for, what does this say? This says line M to be parallel to line N and line Q to be parallel to P. So what else needs to be going on here? So let's look at angle 2. We have angle 2. I don't like that. Let's just go with this. How about we use our mathematical stuff? Angle 2 is going to be equal to, angle 3 is going to be equal to, and then angle 4 is going to be equal to. Well, if angle 1 is equal to 110 degrees, all right, angle 1 is equal to 110 degrees, and if these lines were parallel, well, I should be able to say, well, angle 1 and angle 2 are corresponding angles. If they were parallel, these corresponding angles would be congruent. So angle 2 should be 110 degrees. Again, if they're parallel, if line N and line M were parallel and they were cut by a transversal, angle 2 and angle 3 would be same side interior angles, and same side interior angles are going to be equal to 180 degrees. So I know that angle 3 is going to be 180 minus 110, so therefore it is going to be 70 degrees. Angle 2 is going to be 110 degrees. Now, if we look at angle 3 and angle 4, if these two, if P and Q are parallel and they are cut by the transversal N, then 4 and 3 would be opposite or alternate interior angles because they're in between the two parallel lines. So alternate interior angles are going to be congruent, and then therefore that would make angle number 4 also equal to 70 degrees. So angle number 4 would be 70 degrees, angle number 3 would be 70 degrees, and then angle number 2 would be 110 degrees. So using some of that information just to make these determinations, okay? And with another example, so as we look at this next example, it says find the values of x and y which make j parallel to k and m parallel to n. So I am looking for values of x and y which would make m parallel to n and k parallel to j. Well, if they were parallel, if m and n were parallel and they were cut by the transversal k, then this angle and this angle would be same side interior angles, and I know that these two things combined would be equal to 180 degrees. So I can write that equation. I can say, well, x minus 30 degrees plus x plus 50 degrees is equal to 180 degrees. Okay, so then I have x minus 30 plus x plus 50 is equal to 180. Combining like terms, I'm going to have 2x plus 20, right? X plus x is 2x, and then 50 minus 30 is going to be 20. And that's going to equal 180, so doing my inverse operations. And then I'm going to divide by the coefficient, continuing to isolate my variable. And x is going to be equal to 80. All right, so if I do some substitution here, if I say that 80 minus 30 is going to be 50, so that would make this angle right here 50. And then I would have 80 plus 50 equals 130, so this angle right here is going to be 130 degrees, this one's going to be 50 degrees. And same side interior angles totaling 180 degrees, that looks good. So x is going to be 80. Now, if k was parallel to j and it was cut by the transversal m, then if this angle is 50 degrees, I know that this angle is also going to be the same side interior angles, which would total up to be 180. So this angle right here, we should know that y is going to be equal to 130 degrees. So we were able to find that given the values of the information that we used and the rules and theorems to come up with those answers. So as we are proving lines parallel, again, those relationships that we previously learned about corresponding angles, alternate interior angles, exterior angles, same sides, conditional statements, all of these definitions keep coming back into play, and we just wanted to be able to apply theorems to determine if lines are parallel and prove lines are parallel given angle relationships. So there we have it as we move forward into these, using all of these wonderful relationships, which help us. Why are they wonderful? They help us solve problems.